Okay, good morning, Professor David J. Reyes. Okay, it's October 10, 2023. The time is 3:31 a.m. Okay, my topic for this morning will be a continuation of my long video format discussion AC machines, and we are now on lesson number 35. Lesson number 35 is three-phase transformer connections. Well, we are just discussing the four most uh, usable connections under the study of transformers. That is the most popular ones. That is the delta delta, delta to Y, YY, and Y delta. These are the most popular connections for transformer. There are other connections, but the conditions for them to occur will be special, what do you call this, condition. We'll do that later maybe. Okay, let's proceed. Uh, the subject matter for this morning will be AC machines, lesson number 35, and the title of the topic will be three-phase transformer connections. Three-phase. So there are actually two methods on how to construct three-phase, okay, or to connect three-phase. It's either that you will assemble a one three-phase as a big unit, or you interconnect three single-phase to obtain the required connection, which is either delta or Y. Okay, let's proceed. We assume for the meantime that what we are connecting is just a three-phase, what you call this, construction. The number one connection is actually the so-called delta-delta. Delta-delta meaning the configuration of the primary is delta, the configuration of the secondary is delta. Okay, these are just the cores. Primary windings, secondary windings. It seems this is the shell type, right? In which, if this is the primary, if this is the core for the first phase, the first winding that will be wound will be the primary winding. Okay, it will be this one. And the match for this will be this secondary winding. And the secondary winding will be wound after the first, the primary winding is done. So the sequence is this: first winding, primary winding. After completing the primary winding, they put an insulation, okay? Then they will try to wound the so-called secondary winding. This is the matches, and so with this, and so with it. I place a designation here, A. This is phase A, phase B, and this is phase C. Why is that so? It's on the, what you call this, it's on the voltage, it's on the graph of the induced voltage. This should be phase A, maybe. Phase B lags behind by 120 degrees. And phase C again lags behind by 120 degrees. So this is phase A, this is phase B, this is phase C. So this is actually the graph of the induced voltage for a three-phase transformer. Okay? Oh, this is the first leg, second leg, third leg. So this comprises just one core. Okay? So as soon as the windings are wound, okay, if you try to put a voltage on the primary, there will be a flux cutting the, what you call this, passing through the core, and which will induce voltage on the secondary. That's why if there is an applied voltage here, whether we like it or not, there should be voltage on the secondary. And this one are, the voltages coming from this one are actually the voltages from the fuse. It should be the step down transformer, okay, which is injected to here. Oh, what's next? For it to be connected delta, it is something like this, delta. We got 3 points on the delta, right? We got 3 points on the delta. So in between 2 points, there is a winding. There is a winding. Okay? So every, what do you call this, every joint points here represents one terminal on the primary, right? So we connected this winding here in this, and the intersection, we bring it out, that will be H1. And we connect these two windings here, right? The intersection here will be here. Then we bring out that one, that will be H3. And the last one that's not connected is actually this end here and this one. So this is a direct connection here. If there is no dot, there's no connection, right? There's a connection here, but there's no connection over here. So mean to say, we connect this line here with this, or the end of the winding here is connected here. And if we try to get the middle point, that will be H2. So it seems it's a delta. This one may be line number 1, this will be line number 2, and this will be line number 3. Okay, that's the simplified equivalent of this one, right? Even on the secondary, it's the same because the connection is delta, right? Okay, I will try to erase this one. Right? If we connect two windings, we could we get the middle the intersection point. We bring that one, that will be X1. We connect these two here, we get the intersection here, we bring it out, that will be X3. And we connect this end here and this end, it is this line here. We get the middle point over here, we bring it out, that will be X2. So there are 3 lines on the secondary, 3 lines on the primary. So for a delta, this should be the connection. This is the actual connection. Okay, this is delta. Delta on the primary, delta on the secondary. Right? Next one. The next connection will be delta to Y. So for the delta, the primary will still be the same as this one, right? So because the primary is delta, right? We connect these 2 points here, we bring it out. We connect these 2 points here, we bring it out. We connect these 2 points here, we bring it out. Okay, we got H1, H2, and H3 already. It is connected in delta. But for the second configuration, it is Y. So the connection will be different. We must have to produce a neutral point, right? Neutral point. The neutral point is this one. Okay, hold on. This is to the right of this winding, to the right. And we connect all those 3. Right. Okay, we connect it to this neutral point over here. So we bring it out, we connect to this point here. So meaning to say, this one, this end here, plus this end is connected to a point, we call it neutral, right? And the other ends of every winding, we bring it out, and that will be the output lines. So the end of this one is this point, point here. We bring it out, that will be X1. For this winding, the other end is actually this one. We bring it out, that will be X2. For this winding, the other end is actually this one, right? We bring it out, that will be X3. Okay? So this is the Y connected, this is delta. So for a Y connection, we got a common point, which is called neutral. Okay? But just be sure this is left, and we merge it into one, that will be the neutral. So the other ends will be the output lines. Okay, for a Y. So this is to the load, connected to the load. Oh, next connection, HCYY, right? HCYY. So the primary of this one is Y connected, the secondary is Y connected. So we will copy this connection here, we put it here, and we copy this connection here, we put it here. Okay? This is left, left, left. Okay? We connect it to the neutral point N. That's a common point. So the remaining ends not connected to the neutral point, we bring it out, that will be H1. We bring it out, that will be H2. We bring it out, that will be H3. That's why. The neutral point is actually here. It's this one. For the secondary, it's still the same. This is left, left, left. We merge it into one. We connect it to point N. That's neutral. It is this point here. Right? This is left, left, left. Right? And for the remaining what do you call this, end of the windings, we bring it out. That will be the lines going to the load. So we bring out this one, that will be X1. We bring out this two, that will be X2. We bring out this one, that will be X3. Okay, so 3 lines, 1, 2, 3, it's 3 phase, right? So for this connection, this is Y, and this is Y, and this will be the actual connection. The last one, it's a configuration Y delta. Okay, I think this transformer is actually for stepping down. So it could be from the secondary line going to our houses from 13,200 to 120 maybe. That's why the configuration is Y delta. The primary of this is Y. So we will be having a neutral point. This is left, left, left. We merge it into one. We connect it to neutral point N. Okay, so the remaining other ends will bring it out. So this will be H1, this will be H2, this will be H3. So these are the primary lines. Okay, and this neutral point in here is this one. It should be here. Oh, my pen is dry. This is N. Right? This is N. This N here is this one. Okay. The secondary is delta. So we'll just connect, we'll copy the delta, right? For the delta, we connect this N here to this. We bring it out, that will be X1. Okay, we connect this N and this N from winding to winding. We merge it, we bring it out, that will be X2. And the two remaining windings that are not connected are actually the par ends. So this one and this one. So we connect it, we get the middle point, and that will be X2. So these are the 3 lines going to the load. X1, X2, and X3 going to the load. The configuration is delta. It seems this is X1, this is X2, and that will be X3. Right? But this is the actual connection. If you try to see it on the, what they call this, with the core in place, right? Okay guys, so these are the most popular connections for a 3-phase transformer. Okay, it's a delta delta, delta to Y, Y to Y, and Y to delta. The main problem here is in the so-called computation of the voltage and current specs for these connections. For a delta connection, there will be a relation for voltages. Okay, what will be the relation of the line voltage with respect to the phase voltage? For the Y connection, what will be the relation of the phase voltage and the line voltage? Of course, they will be different. Even the current. The current for delta is different from the computation of the current for y. Okay? The current here is different from this one. So the next time around, since we now know how to connect a transformer, and the computation, okay, which is a scope of the board exams, right? We should know what will be the relations of the so-called phase voltages, okay, and phase voltages and line voltages, and phase current, and line current. Okay, so in relation to the phase voltage and what do you call it, line voltage, phase current, and line current, we should compute for the so-called true power handled by these transformers. So there is a relation for the power, true power that could be carried by the transformers in terms of the phase voltage, line voltage, phase current, and line current. And for both Y and delta, the relations are actually different. That's why that will be the next topics after this maybe, yeah, okay? Because after knowing how transformers are connected, of course, the next topic will be the calculation and how they will handle current or load specifications. Okay guys, these are the connections most popularly used for transformers. It's delta delta, delta to y to y, and y delta. Okay, good morning from Los Angeles. This is Professor David J.